electric three-wheeler segments. Batteries form a critical component of electric vehicles, accounting for almost 30 to 40% of the total cost of the vehicle. The performance and safety of EVs are also linked with these batteries. And in this webinar, we will be sharing our observations on the recent EV fire incidents recorded globally. Before we go ahead, let me introduce to you all to today's expert panel. We have Dr. Judy Jeevarajan, Vice President and Executive Director, Electrochemical Safety Research Institute, Underwriters Laboratories. Mr. Abhishek Ranjan, Senior VP, Strategy, Utilities and Retail, Renew Power. Mr. Arun Shreyas Reddy, Founder, Race Energy. Dr. Rashi Gupta, Founder and Managing Director, Vision Mechatronics Private Limited. Mr. Ketsu Zhang, BYD India Private Limited. Mr. Sanjay Gopalakrishnan, Senior VP, Electric Passenger Vehicle Business, BYD India Private Limited. Ms. Neha Tapadia, co-founder of Sion Energy Storage. Dr. Parveen Kumar, Senior Manager, WRI-India. And Mr. Pavan Munukutla, Director, Clean Mobility and Energy Tech, Sustainable Cities, WRI-India, who will be our moderator. Before we start, we have a brief presentation by Mr. Vivek Tripathi, who is a project associate with WRI-India. He would be presenting some observations on the recent EV fire incidents recorded globally. Over to you, Vivek.
Thanks, Amrita. So I'll share my screen. Is my screen visible?
Yes, yes.
Okay. So I'll be giving the knowledge presentation for this session titled Fire Safety Readiness of Electric Vehicle Batteries in India. So here we have the outline for this session. I'll start with the concerns of EV fire hazards, and then I'll detail on the fire hazards due to battery failure. And lastly, we'll see the prevention and mitigation techniques to minimize chances of EV fires. So giving the introduction, fire safety in electric vehicles is of prime importance. It can affect consumer trust and influence EV adoption rates. Majorly, EV fire accidents are associated with the battery failure. And recently, India has seen a series of fire accidents, especially in the E2-wheelers. As per surveys, these cases have increased consumer concerns around safety of electric vehicles by 8 times. If similar accidents prevail to occur, confusions around safety of the technology will dominate among consumers. Although there is so much of hysteria created around safety of the EVs, early adopters of the technology have proven that EVs are safe if deployed properly. As per US-based research, fire accidents are least likely to occur in electric cars, and the number of recalls for EVs is almost also comparatively less. Now, looking at the status in India, with increasing popularity of electric mobility, the number of EVs on Indian roads have increased significantly over the past few years. However, the technology is emerging in the country, and there are certain critical challenges for the Indian EV industry that needs addressing to prevent safety concerns, some of which include the quality concerns for the imported low-quality cheap battery pack and cells, the adoption, which is mainly dominated by the E2-wheelers and the E3-wheeler, which lack sophisticated battery management system and the thermal management system. There is also a lack of know-how regarding the operation and maintenance of EVs. And lastly, the operational condition. India, as it falls in the tropical region, has an extreme operational condition for the electric vehicles. As we can see from the lists for selected EV fires in India, recently many E2-wheeler fires have been reported. Among them, major share of fire occurred while the vehicles were parked, followed by incidents while charging. Government has been taking these safety concerns seriously and has started investigating causes for the EV fires. The Center for Fire, Explosive and Environmental Safety, which is a laboratory of Defense Research Development Organization, DRDO, is investigating the E2-wheeler fires in India. Now, looking at the global statistics, EV markets globally are evident to many fire accidents. Review of these fire accidents have shown that battery fire cases in the EVs range from fire in parked vehicles to all other operational modes for the EVs. However, research reports suggest that majority of the fires were observed in parked vehicles, around 33%, followed by charging or due to collision or other modes and reasons. Now, in India, e-two-wheeler fires in the parked conditions have been increasing. To understand the trends of fire safety incidents in small battery packs, we can see the plot in the right. The plot gives the number of fire in the personal mobility devices, which includes electric scooters and electric unicycles and power-assisted bikes in Singapore. The number of fires for the 2020 revealed that of the overall fires, around 70% of 46 fires occurred at residential premises, and major reasons for them were cited to be overheating of the battery packs due to overcharging. These numbers point to a serious safety challenge for India, where similar situation can arise if mitigative actions are not taken. Now here we have the causes for the EV fires. Majorly, the ignition of the vehicle is due to the ignition of the battery pack, and which has certain causes, as we have shown. The internal short circuit, mechanical deformation and impact, external short circuit, charging, discharging, exposure to high temperature can be several possible causes for these battery failures. And now in the next few slides, we'll be discussing these causes by classifying the fires broadly based on the operation modes of the vehicle. Starting with the spontaneous ignition of the battery pack while the vehicle is charged. As we have seen in the previous slides, that fire incidents in parked vehicles have seen the most number of cases. Thus, spontaneous ignition of the battery packs can be a serious challenge. Research reports points towards internal short circuit to be the major probable reason for such failures. The table shows global examples of fire safety incidents in parked EVs. Causes for the fire reports were reported to be the battery failure due to internal short circuit. And looking at the first case, where investigations for the reasons for the spontaneous ignition in Hyundai Kona was cited by the EV manufacturer to be faulted battery cells, which caused fire defects. Thus, it is critical to ensure robust testing for quality check in battery cells to prevent similar failure chances. Now, we will look into EVs catching fire while in operation. Now, charging related EV fires is another major concern which requires attention, as the number for such accidents falls second in line. Battery researchers and experts have pointed overcharging our maximum voltage limit and high speed charging to be major reasons driving these concerns. Results from overcharging tests show that internally within the cell, dendrite formation due to lithium-ion overcrowding at anode may puncture separators, resulting in short circuit and thermal runaway. Chances for overcharging safety concerns in EVs increases due to certain reasons, some of which include incorrect detection by the charging control system, wrong charger, or faulty BMS operation. There is also a serious debate in the industry concerning relative stability of different lithium-ion chemistries. LFPs is generally considered more stable as it has higher thermal stability. However, this does not apply when we compare overcharging stability of different chemistries. Test results comparing relative stability of different chemistries under different abuse conditions have given conclusions that NMC and NCA have more SOC buffers, around 135% and 130% compared to LFP, which has 5% of 5% of SOC buffer to prevent thermal events due to overcharging. Thus, overcharging stability is highest for NMC, which is followed by NCA and LFP chemistries. Now we'll look into the collision or accidental fires. Collision or accidental fires are common to both EVs and conventional IC vehicles. However, collision of EVs with external objects or road debris can mechanically deform battery packs, which causes internal short circuits and thermal runaway. The European Union funded EverSafe project studied undercarriage impact tests for Toyota Yaris EVs with T battery configuration. Conclusions from the project related to design and battery pack placements points out that the floor battery configuration with low ground clearance combined with the design where complete removal of front axle is possible has the most safety configuration. The table shown below gives example of EV fires associated with the collision or accidents. Tesla, which is a big ambassador of electric mobility globally, also had to address safety concerns initially due to a series of fires in its Model S after collision. In 2014, Tesla provided titanium shields for reinforcement to prevent fire incidents in Tesla Model S battery packs due to collision. Now, looking at other reasons for the battery fires, EV fire cases recorded globally have shown Possible reasons for accidents due to external short circuit or exposure to high temperature of the EV battery. Although chances for these are low, but exposure to high temperature can indirectly be a challenge for India, where operational temperature reaches extreme values due to tropical climatic conditions. Research conducted by different laboratories on lithium-ion batteries have shed light on increased degradation rates at high temperature. Self-heating rates of the battery increases with high ambient temperature operation, which can increase chances for safety concerns in the batteries. Battery heating may be due to other reasons as well. Manufacturing faults like loose electrical connections and exposure of the battery surface to external fires can seriously pose a safety challenge. Below are shown global cases of fire incidents falling in this category. Probable causes of the incidents include immersion in water, seepage of water, heating due to improperly tightened electrical connections, or exposure to high temperature. The last case of Beijing, China, had led to serious damages where 80 e-buses burned in park situation. After fire investigations pointed exposure of the battery surface to nearby fire as the reason for such mishap. Now, looking at the EV recalls and OEM actions, fire accidents associated with the battery failures can derail business plans for OEMs. With consumer trust at stake, cases of such failure can directly affect sales figure. Globally, many OEMs have recalled their EV models and taken mitigative actions to counter the safety risks associated with the batteries. A summary of some selected global EV recalls is shown here. Among all the examples shown here, recent recalls by GM and Hyundai have been a costly proposition for the OEMs. The companies initially had recalled the vehicle for mitigation of probable causes. However, even after 2 recalls, incidents of fires in the model has led to mass replacement of the faulty battery modules free of charge to the customers of the suspected models. Now we'll look at the regulation and standards for the fire prevention of the electric vehicles. Traction batteries undergo tests to certify their fitness for the automotive usage. These tests are published in standards, and countries globally have published standards for abuse tests, aligning closely with their conditions and the global requirements. Table shows the list of requirements and standards for safety of traction batteries in different countries. We have the case of China, where the ministry has recently introduced 3 new national standards for safety of traction batteries and xEVs. These new standards addresses the safety concerns of EVs, electric buses, and the traction battery safety requirements, which is specifically to the cells and the packs. Our esteemed panelists will provide more insights on the requirements and standards for safety of EV batteries in the following session and the panel followed. Lastly, we have the prevention and mitigative techniques. As we have discussed previously, recalls can be a costly proposition for OEMs as chances for costs incurred due to replacement of the battery packs exists. Emerging markets like India must reflect on global activities surrounding safety concerns of the EV battery and work on preventive measures to cease chances of failure. To overcome risk of fire safety, several practices and techniques have been suggested by experts, which include quality testing and approval of the cell and battery pack while they're being manufactured. There should be robust battery management system and thermal management system with the batteries for high accuracy and effectiveness for the and prediction of the future faults. There is also a need for technology innovation and selection of the batteries for Indian operational conditions. Indian EV market is highly driven by cost effectiveness and performance requirements from EVs. Currently, India relies on imported batteries which are not designed for the operational conditions and performance requirements specific to India, giving rise to serious safety concerns. OEMs must be knowful about battery technology and design battery packs specific to the requirements. Selection of the technology also plays a crucial role. Here, results for the structural innovation and the chemical composition changes for improved thermal stability of NMC variants have been shown. The results show that with increase in nickel content, the thermal stability decreases, and increase in manganese and cobalt content reduces cell performance. As per the results, NMC 532 provides optimal balance for the stability and the performance requirements. Thus, OEMs also must look on the trade-offs associated with the performance and safety of the battery technology and select based on requirements and conditions. With this, I would like to stop the presentation, and here are some of the discussion points for the panel to be followed. Thank you. That's all from my side. Over to you, sponsor. Thank you.
Thank you, Vivek. This was really insightful. I would request Dr. Parveen to start the panel discussion, as I think Mr. Mulukutla is running a little late. So over to you, Parveen.
Thank you, Anandita, and thank you, Vivek, for setting up the context for the today's panel discussion. And let me start by welcoming our esteemed experts for this panel discussion, and also good evening to all the attendees. And let me start with the Dr. Judy about the. So in recent time, we have seen several fire accidents, and especially in the electric two-wheeler and electric three-wheelers in India. And these, as Vivek has mentioned in his presentation, that in latest survey, it is showing that this has increased the concern among the consumers regarding safety of EVs, and they are a bit suspicious about suspicious about buying the EVs. They're thinking that how safe it will be, and recently in last 6 months at least we have seen several accidents. So in this context, I would like to ask you that in your opinion, what are those key steps at the government level that need to be taken to address this issue of fire hazard in EVs, and what steps do industry players need to take to ensure a high level of safety in EVs?
Sure. I think the first thing you already have in your list of topics is standards. I'm not sure that India has standards for two-wheelers and three-wheelers. There are some standards that are in the IEC and SAE that can be used in the meantime. And what I would recommend is that people start actually meeting those standards first, doing all the required testing, both, starting from the cell level to the battery level, and actually testing at the battery level under off-nominal conditions, which include not only, all the electrical hazards, but also the thermal environments and mechanical environments. One of the things, I think one of the things that, let me see if I can increase my volume. Okay. One of the things that people forget to do or think about is that they need to look at the environment, like the mechanical hazards. There's so much vibration, and there's so much there could be shocks depending on the road conditions that can actually change a lot of things inside your battery packs. The interconnects can move, if there are nuts and bolts, those can move, and those can also cause a short circuit in your battery pack if those come loose. Of course, temperatures, whenever you have higher, warmer temperatures, they are going to cause more decomposition of the electrolyte and also destabilization. So all of those things should be tested, and as a minimum, the standards should be met. The standards are not going to take it to extremes. It's only going to confirm that your minimum tolerance is there. So first you need to take it to the extremes and test it, and then you come back and do your standards, so at least the minimum requirements have been met. And I think if the government imposes that on all the EV manufacturers, including the two-wheelers and the three-wheelers, I think that'll help a lot. There are a lot of other, aspects that I can talk about with respect to safety of the cell designs, and putting cells together, not understanding the hazards at the battery level. But I'll wait for the other speakers, and then we can revisit that part.
Thank you, Dr. Judy. So I will come back. Okay, I think Pawan has joined. So okay, so Okay, I'll go to Dr. Mr. Abhishek Ranjan. And recently we have seen, as Vivek was also discussing, that there was a several fire accident during charging of EVs. And in India, we see that a lot of people charge the vehicle at home or at the residential locations. So I will ask, I think, Dr. Abhishek Ranjanji, what kind of safety protocol need to be deployed to ensure a high safety during the charging of EVs at the home, office, or shopping malls?
Thank you, Dr. Praveen and WRI for hosting me here and giving me opportunity. Am I clearly audible and visible, please?
Yes, Abhishek ji.
Yeah, thank you. Sorry, I'm traveling, so some background noise might be there. And yeah, so Madam was talking about the standards for charging for batteries, for safety, fire safety, etc., which is there in IIC, but apparently it's not there in India. I would like to slightly differ. Over the past 3 years or 4 years, several standards have been published in, I'm talking specifically about the EV and also the static personalization BACS. I had opportunity to install battery storage at a distribution transformer level as well. So there we did have IS, and wherever we didn't have IS, we had adopted IEC and UL as well, both. Coming back to EV, one has to talk about standards and their compliances to ensure such fire hazards are not there. Especially the cases which we saw in the presentation. There we had an issue where either it was overheating, overcharging, the battery was not up to the mark, the cells were not up to the mark. The charger itself was a problem. There was no proper communication between the BMS of the battery and the charger, and therefore overcharging happened and explosion happened. IS 17017 and stroke IEC 61851, the standard which is already there for the EV conductive charging in our country, and there are 25 parts to the same. Part 21, section 1 talks about the off-board chargers, and onboard chargers, and section 2 talks about the off-board chargers. So in Delhi, for example, we had launched a single window scheme last year in November, and we had said any charger can be there, especially the LEV AC chargers, which were the first standards, were also notified on 31st August 2021. And we said that any charger for curbside parking, two-wheeler or three-wheeler, that charger has to be certified and by this IS standard or LEV AC charging standard. Now the point is, each and every point about the safety aspect, conforming to this IS 17017 certification is mandatory. Otherwise, they're not allowed to be installed, whether in mall, homes, offices, or even the curbside. But if there are certain users who go without such thing and they're inviting problems for themselves. So we are advising people that you go for only the registered chargers, and also the charge point operators can operate those chargers only. The second point is the CA measures related to the safety of electricity supply, the amendment regulation 2019. So it specifies clearly about how a public charging stations should be installed, commissioned, and also a semi-public in terms of, say, for example, basic electrical safety norms, for example, lighting arrestor, or maybe ELCB, earth leakage current breaker, circuit breakers, or maybe earthing, part of it, minimum safe distance, connection, locking of the interlocking of the connectors once the charging is happening. During the session, nobody can forcibly unlock. Even if there is a variation in the voltages, automatic switch off, automatic cut off. So those basic protections are already enshrined and they were published in year 2019. There is another regulation called CA Technical Standards for Connectivity of Distributed Generation Resources regulation, and that was notified in 2013. That has also been notified and amended to include the EV charging point and EV charging station as entity recognized actually in the regulation, and they have to be satisfied using these CA regulations. So Dr. Praveen, to answer your query, the DISCOMs, for example, or any other entity, including the CPO, they have to conform to these standards. Only then they are going to get a specific EV related metered connectivity from a discom. So that is the bit the discoms are doing, and this is how the CPOs can also do in terms of public and semi-public charging stations. Over to you, Dr. Praveer.
Thanks, Abhishek ji. Pawan, now over to you, and you can.
No, thank you, and apologies for joining late. And I'm hoping to, also learn from this discussion. But Abhishek, I had a question as a follow-up to you. That do you see a bigger role for discoms and utility companies in this whole, safe charging infrastructure deployment?
Discoms as a super CPOs, okay, super charge point operators. Why? Because the discoms are nothing but they are B2C entities, business to consumer, end to end. So their interest is in deploying distributed EV charging points everywhere. And as we talked about malls, schools, hospitals, because this is the beauty of EV. You can gain your, kilometers in your vehicle anywhere you like, wherever the electricity is. So discoms being the ultimate licensees or authorities or maybe the responsible organizations who are to ensure a reliable, safe supply of electricity, they are the natural choice for playing the role of implementing safe EV charging network everywhere. So definitely it is there, and in many states, for example, in India, for example, MOP has notified the discoms as a default state nodal agency. In Delhi, for example, discoms are private agencies, private discoms. So they have notified Delhi Transco, DTL as a entity. Otherwise, state discoms are the state nodal agency. So they do have a role in terms of electrical safety, technical safety, and safe EV charging. That is one. Second role is about commercial aspects of it. Investment by the discoms in the EV chargers per se under the CAPEX or the OPEX mode, which is unfortunately not allowed as of now by the respective SERCs. That may also take a modification. It may be modified in years to come when it is seen that need-based EV charging in some disadvantaged sections are required, where for two-wheelers, especially and three-wheelers, EV charging public network has to be laid on. So one such attempt is by the government of Delhi, and many such things have to be there, allowed under the CAPEX or OPEX by the SERCs for the discoms on case-to-case basis. We have seen this in California. Maybe the same thing can happen in India as well. Pawan.
Thank you, Abhishek. I'll just come back to you, but let me pose this question to Arun. Arun, just quick two-fold questions for you. First, how ready you feel batteries are in India to really withstand the operating conditions that we have in India, the rough usage and the extreme weather conditions? And then I have a follow-up question also. So Arun, if I can have you come in.
Sure. I think, there's two levels that we have to talk at, right? One, I think, in the presentation also that was brought up, one is definitely at the cell level and the other is at the battery pack level. Since cells are not made in India, of course, by nature of the cell itself, they're not designed for the Indian weather conditions, right? So with every cell manufacturer sort of mandates a certain operating conditions. Typically, if it's an NMC cell, it's between 25 to 35 degrees. Certain kind of operating conditions, how much you can discharge and how much you can charge. As a battery pack manufacturer, that's what is in the scope of most Indian battery pack manufacturers. Is that how much of it can you maintain and operate, and then utilize that, and you put that battery pack, you put those cells in that operating window itself, and you not push beyond those temperatures and beyond those use cases, despite what happens in your vehicle application. So a lot of times what happens is in a lot of these cases, the fire cases, what's specifically happening is a different kind of sizing of the battery. I think, if you just want to keep it very simple, a sizing of the battery pack, very basic factor, which makes the battery pack overperform and operate it outside of these operating conditions that are mandated by the cell manufacturer. Once that is exceeded, it kind of becomes, it leads to all of these issues, right? So as such, as an Indian industry, typically most Indian manufacturers who are spending a lot of time in R&D, spending at least a couple of years, 2 to 3 years, designing their own battery pack and testing out the battery pack, it takes this amount of time to just ensure that the cells that you're importing from which has been developed for a cooler condition and to make them work in the Indian condition, that's the kind of level of R&D that takes. And if you sort of skip through that, or if you just purchase a battery pack again built somewhere else, it's very likely that you will end up with such situations. So yeah, it's up to the OEM to choose the longer path to be safe, or go after fast deployment, and could lead to such incidents.
So, one thing I want to ask, Arun, so do you think NMCs are not suitable for India because you said it's 25 to 35 degree of operation, but we have like a summer temperature, especially in, will go up 40, 45. So what do you?
Yeah. No, absolutely not. I mean, we use NMC cells all the time. I mean, our complete battery pack runs on NMC cells, and especially for swappable battery packs, what happens is NMC is the only cell that gives you that sort of energy density, which makes it ergonomic. Because if you go for an LFP cell, if you have to give like a 1.5 or a 2 kilowatt hour battery pack, that goes upwards of 13 to 15 kilos, which doesn't really make it swappable. So the only option that you have is an NMC cell. See, we are in a world where cell technology is moving really fast, and with higher energy density cells, these kind of challenges are inherent. And so with NMC cells, when you're using NMC cells, for a lot more, R&D needs to be done in terms of how do you ensure that these cells are operating inside that temperature window, right? So we are the only swapping player in the whole world which actually has cooling systems with inside the swappable battery pack. It's very challenging because the battery pack is moving between a vehicle and the station. You got it, outside somewhere else, and it's being operated everywhere else. So it's kind of tricky. But when you're aware of those consequences, when you're aware of the kind of cell that you're using, you should also be prepared to deploy these systems to ensure that that cell is operating in that conditions. If you don't, then might as well not use it or face such safety issues that would come up.
Just a quick follow-up. So we have been hearing, the finance minister announced about this whole battery swapping policy that will be introduced, and I know NITI has been working and they have had some preliminary discussions. But is battery swapping a solution, at least in the two-wheeler, three-wheeler space, that would really make it more safer? I mean, I'm just asking this, Arun, and also to any other panelists who would want to respond on this.
So you're asking from a safety perspective, battery swapping as a safer solution? Is that what you're asking?
Yeah, correct.
Yeah, I mean, see, the thing, what I think the biggest advantage with swapping in such situations, a couple of things, right? Firstly, the charging related aspect of the whole operation of the vehicle is no longer with the customer. It is with the swapping station operator or the swapping manufacturer, whoever is basically, because the batteries charging in these conditions in a controlled environment. So for example, what we do is with our stations, right, we ensure that the batteries first, whenever it comes from right after a heavy usage from a vehicle, we ensure that it's cooled down first. It's cooled down to about 20-25 degrees. It takes about 15-20 minutes to do that. Then we start charging. And then once the charge is completed, we again cool it back down and then give the battery pack out to the customer. So with swapping, the inherent nature of the fact that you're not in a rush to quickly push out the batteries, or you're not in a rush to quickly move on to the ground after charging, and gives you ample amount of time to ensure that the batteries are safely charged. And also, we are continuously monitoring as well, right? Every battery pack has each of a battery pack has roughly 5 to 6 sensors inside, which monitor temperatures, currents, voltage, and we can constantly have alert systems as well. Both high temperature alerts, both low temperature alerts as well. If any of these thresholds are crossed, and then there's a certain buffer on top of that, you can immediately cut off the charging. All these kind of safety parameters can be brought in because of the inherent nature of the swapping being that the charging is in the control of the manufacturer. So it's definitely much safer. And yeah, so I think this could easily be one of the quicker solutions to these safety issues.
Thank you, Arun, and let me now bring in Dr. Ashi Gupta. My question to you is on if you can really see why we have suddenly seen a spurt of, this whole fire accident, specifically in two-wheeler space. And do you think that we have enough safety standards and regulations in place?
Well, what I personally feel is that the two-wheeler space was more focused, and it's a large upcoming market. That is why, since the faster adoption, the more reasons you have for, it's more number of vehicles on the road. So definitely you have more chances available of fire out there. Now, when there are less vehicles, you will not see, of course, more fires out there. So it's directly proportional to the number on the road. Now, the thing is about the standards, if you see, yes, standards are there, but then how much of it is complied to? That implementation is a feature that lacks sometimes. Quality, robustness lacks sometimes. And do we really have enough testing facility in India is my question. A counter question to what you've asked me. Because I really feel that we need to step up our game for having a good, robust testing infrastructure. We just cannot rely on just one or few labs, around and just do that. No, you need to have multiple testing facilities, and we need to do something to innovate, as in something that we require for our own country, and not just copy paste from the neighbors or the European countries or the cooler countries, whatever. We have to design something which is for our tropical region. And also we need to do a lot of engineering around the battery packs. But it's just not just that you get a few cells, you just screw the terminal, just screw them up, just weld it up, just put a circuitry, and then you're good to go. It's much more than that. And we need to have good amount of, I can see Praveen Kumarji smiling, Judy smiling, and that's exactly what is happening in the market. And everyone is a battery expert. Everyone is a EV expert. Good, we have a lot of experts then, and so we should have less fires. But that's not the scene. So we need to step up our game in testing. We need to step up our game in robust standards, implementation of these standards. We have lesser fires. And you know what? It's okay. We have had fires, fine. But are we learning our lessons here? Are we ready to adapt and understand where we have gone wrong? Are we ready to bring about that change? If yes, then we will not see more fires in May and June, or maybe next year. We all are aware that thermal runaway is a problem that we all are going to face. So what have we done for it? We've been under a lot of pressure to get the things out into the market, and there has been a lot of pressure on the EVs. But then are we really tech ready? We need to work on that. And we will see less amount of fires then. We will see less amount of failures. It's not just fires. Fires, yes, is a major hindrance. I mean, almost 5-6 people have already lost their lives out of it. So we need to work around it. Have we worked enough on the BMS standards? Have we worked enough on having BMS testing done separately? I mean, we are just talking about battery cells and packs. And, most of it, the cell is just tested. We do not have enough testing facilities for higher current rating cells. We have it only for the portable kind of small cells. But what about the higher rating cells? We need to have much more infrastructure coming into place. When you have much more testing, you need to have more stringent standards out there. And you need more implementation of these stringent standards. And these standards cannot be just copy pasted. You need to have them modified for our suitable, our country and the way we work and our mentality, India is like sab chalta hai. I'm going to use a Hindi word, though I have panelists from across the globe and maybe audience from across the globe. But then we have to change our attitude as well. Quality comes at a price. You just cannot have the cheapest and the cheapest and the cheapest. And you think it's going to work the best, then that is not going to happen. You really get to realize, that you have to have some value engineering coming out of this. And I hope with all of these fires, we all learn our lessons and we all make something which is very, very robust. So standards, testing, and skill development. We need to train our people. We need to step up the safety game in terms of, well, I can see one question also. Is it possible to offer high capacities EVs at affordable price? Now the question is, what is an affordable price? Losing a life, is that an affordable price? So it's up to you as a consumer to decide, what is an affordable price. Your life is much more valuable than a TV, right? So think about safety first. Also, we need to step up the game on understanding what skill set do we require. Are we really having enough skills, trained technicians, or even trained manpower around us to create right kind of quality and right safety products that we really want in the country today? So these are the three aspects I suggest that if we can really implement, it will work.
I have a quick follow-up. Thank you, Dr. Asha Gupta. I have a quick follow-up question that, the quality of cells has been a challenge. And of course, you're saying testing and standards is one way. But I'm also trying to understand, is it a bigger issue of the supply chain and the geopolitics? And are we really able to address that, are we getting, is it that our startups or our innovations are asking for cheaper cells, or is it being dumped in our markets? I also wanted to understand if you or Dr. Judy or anyone has some perspective, but Dr. Ashi Gupta, yeah, please.
Yeah. So the thing is, you know what? When there is a demand, there is something being done. If you do not create a demand of anything like this, you will definitely not get that kind of a material. So it's both ways. It's not one-way traffic, it's both ways. So we are also one of the reasons of having such kind of creating a dumping ground in our country. If we say no, we will not accept such things. We will not accept an inferior quality product. Obviously, nobody's going to sell you that, right? So it's a both way thing. And there is also a lot of pressure, like I just said, there's a lot of India is an extremely price sensitive. I will not just say very price sensitive. It's an extremely price sensitive market. Like even in the chat box, immediately we came up with a pop-up answer that 50,000 is what I'm looking at an affordable price. Okay. From your perspective, okay. But from the technology perspective, is it possible is the question. So what happens is there is a lot of pressure on the startups or not just startups or any company for that matter to come into that range. So there is a limitation even to the economies of scale. So what do you do? So somewhere you will have to compromise. Somewhere something goes wrong. And that is what we need to tackle, understand, target, and rectify all of it. So it's a both way thing. Both are under the pressure, and it's a matter of convenience. How does it matter? Few I can make my few bucks and I'm out of the game. How does it matter? So honestly, that's the story. It's and there's these mergers, acquisitions, and then you don't even exist. So it doesn't matter, if there's a few things here and there if something happens. So that's the attitude. So what you need to change is the attitude, and it should be a no compromise attitude, and that is when I think this would work out. But yes, it's a both way thing.
So I would like to add to that. Uh, so yeah, you did a great job, Rashi. But let's say you're buying, cells from other countries, which is inevitable, right? When you don't have your own manufacturing facility. But if you do your screening really well, and you do all the bottom line things, and then you have a good design, and you go in steps, then once you establish that, then it is a little bit more easier as you build along, making sure that your incoming product is good, and then the number of steps is reduced once you invest that initial investment in understanding what you're getting. And I know that chemistries like NMC were thrown out, but I'm not sure how many people who buy these cells actually know the chemistry. They're just taking it in the in what is told to them, right? See, we do a lot of SEM and EDS to find out what exactly is the composition of this particular cathode or the composition of this particular anode. But I don't think everyone is doing that and understanding what they're working with. So there's also, like it was mentioned, some things are heavy, some things are lighter, but people should still have a basic understanding of what they're working with. So you do your initial, analysis, thorough analysis and understanding, build upon it, and then after that, what we call a random lot certification or random lot sampling test to confirm that what you got in your second or third batch is the same as what you got in the first batch. So I think that's how it should go, rather than just, like you said, falling under pressure and trying to meet the demand before knowing what you are really working with.
That's what exactly I wanted to add, ma'am, saying here that see, IQC is one thing. So are we trained? Is our manpower skilled? Are we taking those steps enough right now? So we need to step up our game in terms of all the three things. First is the standards. Of course, many are in there, so implementation, then stepping up into quality training, in-house training, and then implementing all of these things together, coming up with a good robust product. So all of this is together, otherwise we will not make it.
So thank you, Dr. Judy and Dr. Rashi. I think quite interesting. And also, I really like this whole idea, right? When we think of EV skill development, we think skill development is extremely downstream in the whole value chain of the EV deployment, right? And you're saying that the skill development is also required at battery level. We are really talking not just that, when a vehicle is being just on the streets, or whether it's about just training and, making them just be familiar with the vehicle, but it is also how your battery systems operate, how is, data, how reliable is it if there is BMS, and are we really able to make sense out of that also? Neha, I wanted to really bring you in now in this context. That do you see that there is a specific chemistry that is actually safe or well tested, and it's really good for India? I mean, putting you a little bit on the spot, but really wanted to understand. Really, are we saying it's LTO, NMC, or LFP, or what are we really talking about here?
Yeah, so basically, I would say that all chemistries have some strengths and weaknesses. So making each one of them eligible for some specific application or a specific kind of operating environment. So speaking of which, India as a nation has their own specific issues other than the other, like different from other countries, and they'll have their own unique adoption strategies. Going back to the chemistries, I would say again, it depends. It really depends on the applications, what chemistry is suitable. So for LFP, I would say it has a really lower energy density and inherent safety than NMC, and it also works well at a higher operating temperature. And also, as ma'am said, that India is a really cost-sensitive market, so it's the price is also reasonably cheaper than NMC. I mean, this sector, I'm specifying the cost because the Indian three-wheeler segment is a really cost-sensitive segment as compared to two-wheelers or four-wheelers, and the space is not a constraint in devices in vehicles such as long-haul buses, trucks, e-buses, and three-wheelers. So the requirement here is to offer a price sensitive battery and a relatively safer battery. For example, in electric buses, there are far more number of cells than in any other vehicle, and definitely your risk is going up over there. So even if there's a reliable thermal cooling system to protect the cells, the probability of something going wrong is quite higher. So in such situations, I find inherent safety of LFP becomes attractive compared to using large number of NMC cells. Coming to LTO, another chemistry, LTO, which is witnessing a steady acceptance in Indian market. Although LTO offers lower energy density than NMC or LFP, it has a very high inherent safety, thermal stability, and high discharge rate. So it makes a really good cell for high power applications such as forklifts, tractors, mining vehicles, etc. But these cells also really work well for defense vehicles. So I would again say that which chemistry is suitable, it again depends on the application and the environmental conditions where the machine will be working. Like not specifically, I'm not talking specifically about EV alone, considering all different applications where lithium batteries can be used.
So fair enough. What would you say about for two-wheelers?
For two-wheelers, again, we have been dealing with both NMC and LFP chemistries, but I really find LFP chemistries working really well. Although the weight increases over there, but still the customer, what we have observed, that he prefers safety more than the range after a point. Like if he gets a minimum basic range of say about, for a moped, about 100 or 200, 120 kilometers, he is still like, he's okay. I mean, so I feel LFP works better in Indian environment.
But is the market really using LFP in the two-wheeler segment?
We have been, yeah, and in a good volumes. So yes, there's definitely NMC is used in a higher quantity than LFP, but it definitely, it's I think we have been, in fact, to tell you, we have been visited by a lot of OEMs now when there are so many fire incidents, saying that we are planning to switch to LFP. So I'm not sure how this will go, but yeah, people, I think it's just a matter, it's more of a trend, I would say, especially the market is so new कि it's more of like एक जन कर रहा है तो, and for many companies, I'm not saying all companies are like that, but एक कोई कर रहा है तो everyone follows that. I would say that's the case. That must have been the case for NMC, definitely.
No, thank you. I think quite straightforward answers, and I would really ask the other panelists to hold on to the responses to really say if they agree or disagree. But let me guess the other two panelists before we really open up for back and forth discussion. So this is of interest to me, and I'm really seeing Dr. Judy and Dr. Rashi with big smiles. So would really really want to see the reactions also. But let me bring in Sanjay, because Neha talked about what is good for buses and what the complexity that it really increases. Specifically for the bus segment, what do you see are the causes of the fire incidents globally? What has been your experience also? I think that's one question. And the other question is also related to, is the safety concern in small battery packs relatively more compared to big battery packs used in cars and buses? Sanjay?
I think probably Mr. Ketsu, he is actually, because I handle the passenger vehicle business, so Mr. Ketsu will be in a better position to answer this. So Mr. Ketsu is also online, I suppose. So because he has been, he bought the first bus in the country, in 2013. So he has been testing buses since then. So I think Mr. Ketsu, can you just explain this? Yeah.
Okay. Really, very. It's really great for me to join this panel discussion. And actually, it's a long time. It has already been a long time for me to be in China. I should be in India. I really miss India. That is my second hometown. I spent almost 8 years in India, but now because of the pandemic, I cannot come to India. It's not because you don't allow me come. It's because, if I go there, government of China, they will not allow me back. So I'm staying. Yeah. So, but yes, fine. Actually, I'm really happy to see that today this discussion, you people are discussing about the safety, but you are not discussing the range. I think this is really good. When all people discussing about the range, that means they need the, the energy in density, and they will talk about range is will always be a problem, but you are giving more importance to the safety. I think this is very correct. BYD as a pioneer in the industry for the electric mobility, electric cars, buses, trucks, and we are also the pioneer in the EV battery. We founded from BYD is founded in 1995 with battery technologies. So we have both experience in the EVs, and we also have experience in batteries. Actually, madam and sirs, and actually I'm not an expert, but as one of the member of this pioneer in the industry, I really appreciate Dr. Rashi's his opinion. We should always give safety first more than the rage. I think more than the rage. Safety will always be first. That is also BYD's attitude. We are always give safety is the first. In China, we tell people that safety is the most luxury features for your electric vehicles. If there's no safety, whatever features you have, that is zero. That is zero. Okay, so in the past few years, NCM or LFP, there's a battle in China. Initially, LFP, then NCM, and again now LFP in China. Now actually in China, more and more OEMs they come to use LFP. They are not considered too much about NCM because, frankly speaking, NCM its problem is there. I don't know it's correct or not, but some people told me that the fire case is 1 million among 1 million NCM battery cells. There will absolutely one case fire. That is a technology. Nobody can stop that. You cannot avoid that. I'm not expert. I don't know it's correct or wrong, but I think from the experience from China and from BYD, we think safety first, and LFP will always be much safer than NCM battery. Just because of that, 2020, we launched BYD blade battery. We do the nail penetration test, and there's no shortage, there's no fire, there's no thermal runaway, there's no fire, no so that is what we did. Well, that is our attitude, frankly speaking. I cannot tell you why LFP is safer than NCM, but I can tell you the facts. The truth is now in China, more and more people, they come to use LFP. And, after we launched this blade battery, just in March 2022, we sold more than 104,000 electric vehicles in March. Only in 1 month in March. That is BYD's performance, and that is also our battery performance. So I think technology is always important, which technology we should adopt. And the first factor we should consider is safety. This is my opinion. And I think from in June we will take our test facility to India. We can invite all madams and sirs come to see the nail penetration test. We will execute that in Delhi, Bombay, Bangalore, all the big cities. We will invite the experts come and see the nail penetration test for NCM and for LFP. You will understand what is LFP and what is NCM. So anyhow, I'm not expert, Dr. Judy. I think you know more than us, but that is the truth. That is what is happening here in China and in the global market. And once again, I really hope that you all can come to visit China soon when it's open. And we would like to invite you to see the complete process of the battery cell manufacturing and the battery module producing, and also the EV assembly. We hope that this kind of panel discussion should always happen in India, because it's required, the standard is required, and we should let more and more people understand which is more important for people, which is more important for the EVs. We cannot allow the fires happen again as confidence to this new industry. The market is just emerging, so we cannot allow more accident. Okay, Sanjay sir, I think I would like to request you to give a little bit more about the blade battery. So that is of sharing, yes.
Yeah, so I think, Pawan, the blade battery which we developed, which we launched in March 2020 globally, I think it's one of the safest battery. As Mr. Ketsu had told, it can even pass a nail penetration test, which we call the Mount Everest, and it does not catch fire. Why? Because the exothermic reaction does not happen. It does not release oxygen, so there is no fire at all. It can withstand, the temperatures will only reach 25 to 60 degrees centigrade when you do this nail penetration test. So it can withstand high temperatures. So I think that is the biggest reason why blade battery does not catch fire. We have even passed a truck over the nail, over the battery, and nothing has happened to the battery. No fire, nothing. So I think, and we launched our first vehicle in the country, the E6 with the blade battery. So all our passenger vehicles globally come with blade battery, which is the safest, in terms of safety and everything. So I think when you actually see that test, officially, when you actually see the test in person, you'll realize what is the difference between NCM and LFP and the BYD blade battery. With the blade battery, what BYD has been able to extract is safety plus range. So our battery can give range up in some of the passenger vehicles. Globally, we are getting range as high as 600 to 700 kilometers. Yeah, that is what is happening. Even our Indian vehicle, which we have launched in India, the actual range, the tested range is 520 kilometers, and all customers are getting up to 510 kilometers, even in India. It has been run more than 30,000 kilometers in the last 6 months. There is no range drop because of the blade battery technology which we are adopting and the safety. And of course, that is why we have been able to maintain this. So I think that is what BYD globally, and we are trying to bring this into India in a big way, the blade battery technology. Of course, we consider safety as important, and then range comes along with that because of our research, which we have been doing since 1995 in the battery technology.
Fair enough,
Yes,
Sanjay. And I think we all look forward to the nail
Yeah.
penetration demonstrations also in
Sure.
India.
Yeah.
So
across cities.
Power, sir,
Yeah.
actually, we will invite you to see the test. Okay.
Yeah.
But before that, actually, I really invite you to test drive our electric cars which is launched in India. I think very soon we are going to launch 2-3 models. We will be very happy to share our experience with all the experts and all the friends in this industry. Whatever we discuss, maybe our opinion is different, but we have one common target. We want this industry grow. Thank you very much, sir.
Thank you, Mr. Ketsu. Praveen, let me bring you in, and to really say, having heard about all from all our panelists here, very interesting and diverse opinion. And before we open it up for reactions to some of the other panelists, I want to hear from you. Like, what should we be looking at as a short-term and a long-term goal? Like, what kind of innovations do we need in the battery safety in the short term, and what kind of technology, whether it is R&D, and where should we really lead as a long term, keeping safety as one of the primary aspects of how the EV industry evolves. Over to you, Praveen.
Yeah, thanks, Pawan. So in the background presentation, Vivek has nicely captured the trend emerging from the fire accidents, and we can see the fire accident at the park condition and charging is having a significant share in the total fire accidents. And this highlights the importance of there's the importance of using a good quality cells and the innovation at the manufacturing level. So how you design, like Dr. Judy mentioned, that you have to design in a battery pack which can just withstand the local environmental and the operating condition. And Dr. Rashi has mentioned that you can't always think about the developing something low cost. Okay, I want to offer a very low cost solution at the cost of safety, because if you just compare the overall cost you will incur if you are using the low cost cells in the battery is much more. In one of the slide, Vivek was showing that so many OEMs have recalled the EVs and they are fixing the safety in their battery. So the cost of recalling the EV and the kind of negative impact this creates in the consumer's mind against the EVs. So if you just take into account all these things, you will find that it's very important to adopt a rigorous approach at the initial stage itself. For example, you should have, as Dr. Rashi and Dr. Judy mentioned, that you should have a very robust testing and certification at the initial level itself, that you don't allow the low quality and substandard material going into the market. Okay, and for example, you should have a very robust BMS system, because if you just allow the normal battery packs going outside, then anybody can plug in, and then overcharging becomes a big challenge. And as Ms. Neha mentioned, that LFP is thermally stable compared to NMC. But what Vivek was telling, in case of overcharging, NMC is relatively more stable. So you have to see this trade-off and work out something which gives you a better and stable ecosystem for your EV batteries. And what was the next question, Pawan?
I was asking about the long term also.
Okay, so long term, so the temperature is one of the challenge for the EV lithium batteries, and all the our expert panelists, they have mentioned about this. And another challenge is, as Dr. Judy also mentioned, that we are using a non-aqueous electrolyte solution into the commercial lithium batteries. So how we address this? So as Mr. Sanjay and Mr. Ketsu mentioned, that they are coming up with the blade battery, and there, if there is some kind of abuse or anything, the temperature is there within a safety range, I can say, what he's claiming. And the other thing is there, that people are working, the R&D guy, people are working towards development of solid state electrolyte batteries. So if you are going for the solid state LIVs, then the stability of solid state LIVs will be relatively safer. And so this highlights the importance of clubbing the very robust R&D ecosystem along with the current technology development, so that we keep on addressing these issues coming out from the experience what we are getting from the current journey of the EV in India, or I'll not say only India, across the globe.
Thank you.
Okay.
Abhishek, I know you have your hand raised. I see you wanted to respond. Please go ahead.
Yeah, sure. We have been talking about the technologies, mainly NMC and LFP. Of late, we have heard something called aluminum air. And Praveen did mention about the solid state batteries or solid electrolyte batteries. Any views as to how safe this aluminum air is? And it's slightly different technology, as I understand from plain reading of the public documents. Any views from the experts?
Praveen or Dr. Judy, anyone?
Well, aluminum air has been studied for, I would say, maybe a few decades. But it's, you've got to look at the practical aspects of it. What are you getting out of it? And how feasible is it to do this? You can think of, something like zinc air, right? You use the air and then you use the oxygen from the air to actually have the electrochemical reaction. But the zinc air battery is a single-use battery. Similarly, aluminum air, if you want to do a rechargeable battery, you've got to regenerate your electrochemical components. And at this point, I don't think it is where, you can get hundreds or thousands of cycles in it. So I think there's a long way to go. And if you look at solid state, we are in a similar condition, actually. Solid state has been said to be very safe, but I don't think people even have a size of a solid state cell that is reasonable enough to do a safety test. You can't do, a safety test on coin cells and then tell people that it's very safe. You've got to do, the safety test on a reasonably sized cell, which is at least 2 amp hour capacity. And then the next step is not doing just a cell level test, it's actually doing a battery level test. And that's another thing that I also wanted to mention. You can't just do, a nail penetration test on a single cell and, have, and I don't know the background between any of this blade battery that you're referring to, but I hope when people are saying they tested a battery, they really mean a battery and not a single cell. So, when you, run a truck over a battery pack, it is even with if it's an LFP, you are going to have a lot of heat produced, the cells going into thermal runaway, And then depending on the nature of your packaging, if that smoke and gas is trapped, then you're going to have an explosion. It's not because of your chemistry, because as you mentioned that the oxygen is limited on how much oxygen can be evolved from an LFP cell. But if all the other gases are trapped, there are many combustible gases that can cause an explosion if it goes above the LFL. So there are so many factors that need to be taken into account in a battery design. And so I would recommend that, don't start taking a cell level safety into a battery level safety, because they really don't even translate.
Thank you, Dr. Judy. And
Dr. Rashi. Yeah, Abhishek, please go ahead.
yeah, thank you, Dr. Judy, for your comments. I was just mentioning this. Instead of rechargeable batteries, which has been a norm these days, I mean, we want rechargeable batteries. Why don't we have a single use kind of thing where, like, for example, aluminum air, when if it is more safe, so we have, as we all are saying, the safety is priority. So if it is more safe, we can have, say, portable aluminum air cells, we can say, while on the go, on the move. And as and when it is fully consumed, we can replace it. Just a thought. So if it is more safe, we can keep that way. On long distances also, no need to recharge. So just a thought. Thank you.
Thank you, Abhishek. Dr. Rashi and
Yeah,
then
can
Dr.
I add in? Can I add into what Abhishek ji just said? I'm going to
Yeah,
go,
please.
thank you. I'm going to bring in a very different perspective. Something ahead of time. But okay, no problems if you think that aluminium air or sodium ion or whatever, any technology for that matter is safe, and if it's a single use. Now this could be both ways. It could be for a single use. It could be rechargeable, end of life, both ways. Are we really working towards creating a second life, and are we really working towards creating a recycling infrastructure? How far have we reached there? Because if you're talking of a single use battery, the amount of waste that will be generated out of this is going to be piles of tons and tons and tons of it. And we need to then really think about the recycling infrastructure, because if you're not sustainable, if you're not having a net zero and if you're not having a complete circle, a circular economy, then you're not going to work. Then it's not viable. It's not feasible. So yes, single use can work. It is good as an option, but then I would urge everyone to think about recycling as well, because that is going to be the next hurdle we all are going to face. And that will be a bigger one than the safety.
Agree. That is true for rechargeable batteries as well.
As well. Absolutely. That's what I said. It could be for both single use, rechargeable, whatever, but we need to work towards a safer, sustainable, and a circular ecosystem completely in all. We just cannot look at one aspect.
Exactly.
Praveen, I know you had your hand raised and you wanted to come, and I also wanted to see if you had some questions to really ask the fellow panelists and take it forward. So yeah, Praveen, please, over to you.
Yeah, thank you, Pawan. Abhishek ji, Dr. Rashi has already captured and Dr. Judy has captured the important points related to aluminum air. And when we talk about different or maybe alternative to lithium battery, so we have to see the trade-off between not only on one parameter, we have to see the trade-off between cost, performance, and safety, and all plays a very critical role. And based on that, we decide about which one will disrupt the market in coming years. And we have seen that till now the cost was the one of the driving factor. Now people are talking about the safety, and Dr. Judy rightly mentioned that at the cell level, whoever understands the chemistry, they get scared when that even the nail penetration, when people say that, I get scared because I know that there is a separator, then you have electrolyte, then cathode, anode, and if you penetrate. So I would like, in future, I would like to understand more about this, that how this addresses all the concern we have at the material or cell level thing. Because when you crush the things, if you are mixing cathode, and even we have seen in some of the mobile, that if there is a rupture of separator, that leads to the thermal runaway. So we have to see how it works. But before, we have now only 15 minutes. So quickly, I will request all the panelists. I will start with Dr. Judy to give one short-term recommendation and one long-term recommendation for the development of safe and robust EV battery ecosystem in India.
Yeah, I think I'm just going to repeat myself. Short-term recommendation is, understand, characterize, and test thoroughly, the design that you're going to produce for your battery pack, starting from the cell level all the way to the battery level, including the BMS. Make sure that the BMS is functioning as you want it to function, and test in the relevant environments. In the long term, I would say, look out for different chemistries, start your research, work with different cell manufacturers, and then do a really good thermal analysis of the design of, what you want to create as a battery pack, and then complete your design and test it in the long term, so you can choose the best that is available in the market. That gives you enough lead time to actually produce something that is safe and that also works for the relevant application.
Thank you, Dr. Judy. Abhishek ji, I know the safety is one of the topic very close to your heart, and you have done a lot of work in Delhi, where you have tried to ensure the safe charging ecosystem for e-rickshaws. So I'd like to get one short-term and one long-term recommendation from your side for the safe EV battery charging ecosystem.
Thank you, Dr. Praveen. The first short term is immediately regulate the two-wheelers and three-wheelers entering the market for public sale and public use. What is happening is, in the name of the cheaper vehicles, substandard vehicles are entering into the market, which are not getting charged as per the appropriate standards, and it is very difficult to control them. And that is what we have seen in Delhi, for example. So immediately bring them under the net, maybe CMVR, and regulate them. That is immediate, because in the name of the safety, we have seen a lot of accidents happening. Long term or the medium term, you can say, is implement a robust check and balance mechanism so as to ensure that whatever standards we are talking about, which are already there in IS for charger safety, for battery safety, especially in the 2 and 3-wheeler segment, because the 4-wheeler segment, the players are big and they would not dare to, cross that line, safety line. Or so mainly the 2-wheelers and 3-wheelers manufacturers, we need to have a robust mechanism to check both the vehicles as well as charger manufacturers, so that they are not bypassing the charging standards and they are implementing it in a full-hearted way. And third, and the most important thing is create a complete circular economy, as we said, a second life of the battery itself and also the charger, how are you going to dispose it right in the beginning. So otherwise we may end up a lot of landfills, as Dr. Rashi was also saying. So that is very important. From day one it should be done. Secondary mining, Dr. Praveen, I know it's very close to your heart. So secondary mining should be integrated from day one. Dr. Praveen.
Thank you, Abhishek ji. Now we'll move to Mr. Arun. So one short-term and one long-term recommendation. And also I'd like to get one comment from you about this, because we are talking a lot about the retrofitting of EVs, especially in the 2-wheeler and 3-wheeler segment. So how safe is this retrofitted vehicles are in India? So one quick comment on that, if you can give, that will be great.
Sure, I'll answer the retrofit bit and I'll answer the former question later. I think with retrofitment also, it's a very similar approach, what works and what doesn't work. In fact, for the same reasons, we didn't take up 2-wheeler retrofitment because we felt it was too unsafe. In a way, we saw all you could do is put in some motor in the front wheel or the back wheel. We saw that the engine of the 2-wheeler retrofitment was like a Honda Activa, for example. The engine is very well connected to the chassis. It's an integral part of the chassis. To convert such a vehicle was becoming a very big difficulty. And we could only go with like a hub motor kind of an approach, which was not really a great quality product. Ideally, you would want to have like a mid-drive motor with a chain drive or a belt drive, which some of the good quality bikes out there utilize. So for that reason, we didn't take up retrofitment of a 2-wheeler. When it comes to retrofitment of a 3-wheeler, what we had to do was we take it as an OEM approach, right? So we had to over-engineer a lot of components, starting with the chassis that is there, the skeleton that sort of integrates our components with the existing body. We had to replace drive shafts as well, because certain drive shafts are meant for a auto rickshaw, cannot handle that instant torque that comes from an electric motor. So a lot of these testings that we've done, almost 3 years, in different conditions and different loading requirements, accelerated testing, a lot of it on the field, right? I mean, there's only a certain extent that you can simulate in your computer. And that also, I think, very evolved simulated models also still end up with like a 20-30% inaccuracy. And that's something that we had to do. And essentially what we ended up with is like an over-engineered retrofit kit. Because, we've converted everything from a 2003 auto rickshaw till like a 2020 auto rickshaw. And every auto rickshaw comes in with its own different suspension worn out kind of a model. The brakes are not working, something. So it eventually ended up to be like that. But I think the bottom line being that it was a simpler design to take up compared to a two-wheeler. And just having to over-engineer it could address a lot of these problems. And that's how we got it done. And now we're out in the market and piloting with 100 vehicles already. So it's going significantly well, and no such issues have come up, right? With regards to your first question, I think a lot of panelists have already given their opinions and their point of views from different perspectives. I think I'll take this opportunity to give it from a manufacturer point of view, right? What things can be done quickly and what things can be done, in a long-term perspective. I think in the short term, if you could deploy some sort of safety alert systems, right? If you could monitor these battery packs, it is never ever the responsibility of a customer to take care of how the charging happens. I think that's the worst thing any manufacturer could ever say. You don't expect Samsung or a OnePlus to tell you how to charge your phone. That's the last thing that you'd expect from your phone manufacturer, right? I think that's something that nobody should do. So I think in the short term, with the products being rolled out, firstly, I mean, the products that are out there, I think they're really unsafe already. Even if one vehicle has caught fire, the whole model itself is in a dangerous position, because it's hardly been a year or two which has been out in the market. And as the time goes on, these products will age, and the thermal runaway, the incidents that causes these thermal runaway issues tend to become more common, right? Like, I mean, the nominal voltage which all the cells are maintained at, the nominal internal resistance which the cells are maintained at, these kind of tend to differentiate between all the cells inside a pack as it ages, and every cell behaves differently, right? So it is very likely that these will happen more frequently as we move forward. So I think the first thing is that we have to call back those vehicles, call back that model, and then do some fix that issues and then send it back out again. That's a short-term fix that can be done. In the long term, I think, again, a lot of you guys have already answered it. It's never ever rush the vehicle into your market. And I think, this is one of the things a lot of people are doing, and not ample amount of testing is being done. I mean, these are incidents that can easily be tested out, right? If you have certain test cases, put it 2x, right? Just overload the vehicle twice as much, put a higher gradient, put in hot temperature, run all of them together. Unlikely that, these are going to happen in normal conditions, right? Just double the parameters. That as simple as that. And keep doing it again and again and again and again. We had a vehicle, a retrofit kit itself, right? Our retrofit kitted auto used to start testing from 4 in the morning till 2 in the night. So we used to have 3 driver shifts continuously driving with about 400 kgs of load. So that's about 7 or 8 people. And Hyderabad, is quite a hot city. 42 degrees is very common. It's a hilly city as well. You have 3-4 degree gradients constantly being there, and you keep running around it. We did have incidents, but these were before it being rolled out, right? So we made changes to the battery pack accordingly. We made changes to the the way the motor takes the power, how much power can be delivered at one point of time, what sort of cutoffs to be given. And that's the reason why we have internal cooling systems inside a battery pack, because we use NMC cells, because we know that it's not easy to maintain those temperatures. That's the reason why we have it. And it took us 1 year to develop those internal cooling systems. It's not easy to put those inside a small battery pack. So yeah, that's something that in the long term, all these manufacturers should be doing, especially if you're using an NMC cell. It's not like we stop ourselves because there's a high energy density cell coming, but it's thermally sensitive. We shouldn't be like, oh, we're not going to use it anymore. We have to keep moving forward. And going forward, there'll be more and more dangerous. I mean, think of an engine, right? You have thousands of explosions happening inside your car every minute, and you're still using it. Everybody's using it. It is safe. So you should also make the cells to be safe like that. So yeah,
Yes.
that's something in the long term
Yeah.
that should be done.
Okay, thank you, Mr. Arun. So now quickly I will ask Dr. Rashi and then Ms. Neha to give quickly the short-term and long-term suggestion for safe EVs in India.
So for short-term suggestion, I'll say we need to have more engineering. A quick fix, at least to what has happened so that we still have some confidence of the consumers. We still can retain that. And we need to abide by these existing standards at least, so that we create a more robust infrastructure and we can do some band-aid fixing. In the long term, I think we need to work on our skill development, right from not just the EVs, but also for the batteries. We need to work out on our skills. We need to create more testing infrastructure. We need to create more opportunities for R&D and development so that we can make something which is more unique to our country, to our environments, and to the nature of our users. So that is a long-term fix I think we can do, and invest in people, invest in a product, come up with something which is robust. And in the short term, please invest in standards because we can do it very quickly. Our country has the technology and capability to do it very fast. So I think this is my take.
Thank you, Dr. Rashi. Ms. Neha, quickly short-term and long-term recommendations from your side.
In the short term, I would suggest that before even choosing the raw material, I mean the cell and the BMS, even before that, designing, integrating and installing aspects of battery manufacturing should be really thoroughly designed, like the designing part should be really thoroughly done. Apart from that, running simulations for failure analysis as well as real-time testing of batteries is really important step that should not be eliminated. Apart from that, various tests for all type of factors such as mechanical, electrical, environmental and chemical factors should be done. In the long run, I would say that I don't believe one size fits all is the solution for EV batteries, because each product, like each EV battery of each manufacturer has a different set of parameters, and to make your battery compatible to the OEM's battery, you should really do the R&D required. In the long run, I would again say that a really smart BMS for early diagnosis and communication for battery faults mechanisms, especially under conditions like fast charging, spontaneous internal short circuit should be developed. Apart from this, advanced fault diagnosis systems for battery fault, sensor faults and actuator faults should be developed.
Thank you, Ms. Neha. And now I'll request Mr. Ketsu and Mr. Sanjay to just share the short-term and long-term suggestion from their side.
So maybe I will do it on behalf of Ketsu. As a as a OEM, manufacturing electric vehicles and looking at long-term future, I think the one thing what all OEMs do is thorough testing for safety, range. That is very important. Durability test for a long period of time. Just to give an example, BYD does globally 1 million kilometers of durability test at -50, +50, all terrain conditions. Everything is done along with the vehicle and the battery. That is very important, I think, in the long term for safety of the passenger vehicles. I think all of the passenger vehicles. In the long run, I think training, manpower, because ultimately we sell our passenger vehicles through our dealer partners. So I think dealers and the service people should be well trained, because when customer comes up with a complaint, all passenger vehicle dealers, electric vehicle dealers should know about the complaint detection. They should be able to do that. So skill training is very important, as most of our panelists also told, how to diagnose the problem and how to correct that problem. You cannot wait for the problem to occur, but you should be able to diagnose the problem in advance. And so training is very important across all our, chain, basically from one end to other end, whether it is supply chain, whether it is our dealer, whether it is our own people. I think that is also very important. Training is the key in the long run for ensuring safety. That is what, as a OEM manufacturer, we'd like to add this, because safety is very important for all of us. So we would, as a manufacturer, or on behalf of other manufacturers also, ensure that safety is very important, and we will take the lead in ensuring that safety comes first for all battery manufactured vehicles. That's all from,
Thank you, Mr. Sanjay and Mr. Kesu, and I thank all our expert panelists for sharing such a important information and insights with our participants. Also, thanks to all the participants. And now I'll hand over to Anandita. Over to you, Anandita.
Thank you, Dr. Praveen. I would like to thank all our speakers for taking time to join this webinar and sharing their views and knowledge, and hope we have more discussions like this in the future. It was an excellent discussion. Thank you all once again for joining, and we wish you a very happy weekend. Thank you.
Thank you.
Thank you, everyone. Thank you.
Thank you, everyone.
Bye-bye.
Thank you.
Thank you.
Bye-bye.